All right, everybody, so part 2 of our video is going to look at what happens when we have an ellipse, except this time it won't be centered at the origin. So we have two possibilities here for these equations, so I'll kind of break this out into two different parts for that. So the new equation, instead of just x squared, we're going to have x minus h. And instead of just y squared, it's going to be y minus k. And the two different things that we're going to see here are it's basically going to change what happens on the bottom. So if we have our y term with the a on the bottom, remember that a is greater than b, that's going to mean that this is going to be an ellipse that is kind of like skinny and it goes up and down. So that's going to be an example like this on the graph, except again, our center now is going to be at h comma k. So whatever the point directly in the middle of this ellipse will be is directly in the center. So if we were to take a look at this, maybe this long and skinny ellipse, actually won't be, here I can just erase this whole thing here. Maybe it won't be directly in the middle. So let's say here's our coordinate plane, and we have this. And that's our center. That would be the ordered pair h comma k at that point. All right, so the second, second scenario here is what happens when same situation, except now a, or a bigger number, is under our x. Well, honestly, exactly the same idea. The only difference is now we're going to look something like this. And our center is still at h comma k. From the previous video, everything else still holds true. So for both of these, b squared still equals a squared minus c squared. And that's going to be essential to solving. Also, we still have these as our vertices, and our co-vertices are still on our basically other side, the skinnier side. So that's going to be kind of the idea of what we're looking at here. And again, the same thing with the focus here as well. And I'll label those as F for focus. So everything else is still the same. We're just taking it and shifting it from the center of the graph. So let's go over a quick example, and then we can kind of take it from there. So if we have something like x plus 3 squared over 16 plus y minus 2 squared over 49 equals 1. The first thing to identify is that our larger value, our a value, is there, and our b value is there. So b is the square root of 16, which is 4. A is the root of 49, which in this case is 7. So we can use this to basically plug into what we have from above. So b squared equals a squared minus c squared. I think my 4% battery is making it difficult for my pen to write here, but we'll keep powering through. So b squared here is 16. A squared here, we cover that, is 49 minus c squared. So we would go through and we would solve this for c squared. So move c squared over to the other side. Maybe this will help if I tilt this up. And once we do that, we'll get c squared plus 16 equals 49. Subtract 16. We'll end up with c squared equals at 49 minus 16, or c squared equals 33. So c, in this case, is the root of 33. And if you want to leave that as a root, that's totally fine. If you want to abbreviate that as a decimal, that's also 100% okay as well. So I would say for this, we can leave it as 33, or we can leave it as, we'll say like 5.7. Either of those are okay. So now what this means is, based off of the information that we have to identify everything. We have to go through vertex, covertex, focus, all of those types of things here. So we'll start off with what is our center? So our center is h comma k. So we'll take our two numbers, and we do the opposite of them. So for our x value, it's the opposite. And then for our y value, same thing, the opposite. So center is at positive 3, comma 2. So if we put this on a graph, our center here would be at negative 3, positive 2. So 1, 2, 3 to the left, and then up by 2. And then next, we know that our a value is 7, and this is a ellipse that goes basically up and down. So we can go up 1, 2, 3, 4, 5, 6, 7. So up here. So that would be negative 3, comma 9. Then we also go down by 7. So 1, 2, 3, 4, 5, 6, 7. So that would be negative 3, comma 5 down. We know that our b value is the distance to the covertex, so we go 4 left and right. So 1, 2, 3, 4 to the right, is that 1, comma 2. Go 1, 2, 3, 4 to the left, is at negative 3, 4, 5, 6, 7, comma 2. And in this case, our focus is 5.7 up from where we started here. So we want to go up 2, 3, 4, 5.7. It leaves us like somewhere in that range. So I'll put that in a different color here. So it'd be around here. And then we want to go 5.7 down. So 1, 2, 3, 4, 5, and a little bit further down here. So it's kind of on top of those points that we already made, but that's the focus. That's the vertex. That's the covertex. And then that's the center. So now based off of this, we have basically drawn an ellipse, and we've identified all of the important points. So for the vertex, we had that at negative 3, comma 9, and at negative 3, comma negative 5. And I'll highlight that here. So that's that point and that point. For our covertex, we have that at negative 7, comma 2, and at 1, comma 2. And I'll highlight those in white here. So that's here, that whole point, and that whole point. The center we've already identified, and then the last thing would be the focus. Or the foci, I should say, because there's two. So this focus starts off at our center and goes up by 5.7, so negative 3, comma 7.7. Then the other one again starts off at negative 3 and it goes down by 5.7 this time. So for that one, we would have to do 2 minus 5.7. It'll get us negative 3.7. And to highlight both of those points, it's that point right there and that point right there. So that's kind of the idea, is that for these questions, we can label all of these things here based off of just having A, B, C, and a center. So the process doesn't change for finding A, B, and C. The only difference now is our point of reference, our center, it just moved a little bit. It's moved left, right, up, or down in some way, shape, or form like that. So I would say the biggest thing to remember is that your A value is your big term, and if it's under the Y, it goes kind of skinny up and down. If it's under the X, it goes kind of stretched out left to right. Other than that, plug into your formula. You'll be in good shape for finding A, B, and C. And then from there, just some careful counting out, up, down, left, right from the center. All right, everybody, ask questions.